All right, today we're going to do something a little different. We're not just talking about code. No, we're jumping into a time machine to uncover a really powerful and kind of timeless lesson in great design. Okay, picture this. The year is 1903. You can almost smell the oil and wood in the air, right? Humanity is right there on the absolute brink of conquering the skies for the first time. And then it all comes crashing down, literally. But this wasn't just a simple failure. It was a total collapse of belief. The money dries up, the workshops go quiet, the whole world basically just throws up its hands and decides, yep, human flight is an impossible dream. But what if you could change all that? I mean, what if a pilot, just a really determined one, could go back in time, not just once, but as many times as it takes to finally get it right? Well, this is the exact problem that gets dropped in the lap of a developer named Alex. So a time traveler comes to Alex with this incredible mission. He wants to hop around through time, right? Trying different years, making tiny adjustments, all to make sure flight actually happens. But there's a catch, and it's a big one. He has this one single non-negotiable rule. When he comes back, he has to return in the exact reverse order of his jumps. No exceptions. How this actually works. Our traveler makes his first jump to 1903. The machine takes that year and pushes it onto the stack. Boom. That doesn't work out, so he tries again, jumping to 1885. The machine pushes 1885 right on top of the 1903. And let's say he tries one last time, jumping to 1927. Well, 1927 gets pushed onto the very top. And there you have it, our stack of time jumps is all built up. Now, here's the beautiful part. To get home, the traveler doesn't need to remember a single thing. The machine just follows that one simple rule. It pops the top item off the stack. So, poof, he's back from 1927. Then it pops the next one, and he's back from 1885. And finally, the last one, 1903. See? No searching around, no getting confused, just pure, simple, last in, first out. Okay, so Alex has the logic figured out. It's a stack. Easy enough. But wait. The time traveler isn't a programmer, right? He doesn't know what a stack is, and he doesn't care. He just needs a control panel that works. And that brings us to the really crucial next step. How do you design the user interface for this thing? So what Alex designs is this beautiful, sleek dashboard with just 5 controls. That's all. There's a button to push a new year, to make a jump. One to pop the last jump to come back. He adds a cool peek button so the traveler can see his most recent destination without actually going. And then just 2 little status lights, one that says is full and one that says is empty. That's it. The whole interface. Now, what Alex has just built here has a name in the world of programming. It's called an abstract data type, or ADT for short. And the best way to think about it is like a black box. It's basically a promise. It tells you what you can do, in this case push, pop, peek, but it deliberately, completely hides how the machine is pulling it off on the inside. Because under the hood, beneath that simple 5-button panel, that's where the real engine is. All the complex, maybe even messy, but brilliant work that Alex the developer put together. And the best part? The pilot doesn't need to know a single thing about how it works. And this separation is everything. On one hand, you have the interface that the pilot sees, just those 5 simple buttons. But on the other hand, you have the implementation that Alex actually built. I mean, did he use a fixed-size array to store the years? Or maybe something more flexible, like a linked list that could grow forever? The truth is, the traveler has no clue. And even better, he doesn't have to care one bit. So, why is this idea, separating what a thing does from how it does it, so genius? Well, this whole principle, which we call abstraction, it basically gives a designer 2 incredible superpowers. Okay, superpower number 1, simplicity for the user. Our guy is a pilot, not a coder. If you showed him the internal wiring, it would just be confusing and totally pointless. The simple interface lets him do his job, period. Superpower number 2, freedom for the developer. This is huge. By hiding all those internal details, Alex can completely rip out the engine and replace it overnight. He could swap an array for a links list, and guess what? The pilot, who only ever touches those 5 buttons, would never ever know the difference. And all of this leads to a really fundamental rule of great design, and this quote just nails it. If your client can figure out your implementation from your interface, you've already designed it badly. Think about that. If your user can guess what's going on behind the curtain just by looking at the buttons, you've already messed up. You've exposed all the messy stuff that should have stayed hidden. So, when we come back from this whole time-traveling adventure, what's the big lesson? What's the takeaway? It's this. Great design isn't just about the cool features you add. It's about the complexity you have the discipline to hide. You know, when you boil it all down, it comes to this right here. The client, our time traveler, he paid for a machine that would let him fix history. That's it. He didn't pay for Alex's clever choice to use a linked list instead of an array. He paid for the functionality, not the implementation. And that, right there, is the heart of any great service, any great product, any well-designed system. And so that leaves us with one final thought, a question for you to take with you. Just look around. I mean, the steering wheel in your car, the apps on your phone, even the light switch on your wall. Where else in your life do you see a massively complex engine that is just so elegantly hidden behind a beautifully simple interface? Because once you start looking for it, I promise you are going to see it absolutely everywhere.